This is a short probability question and it concerns independent events. Just giving you a hint there. What is the probability of getting a number divisible by 3 in each of 3 throws of a dice? So we have 3 events and, well, 3 events that are identical, so we're just going to give them all the same name. And we're going to call this event T, and the number you throw is divisible by 3. So it's either 3 or 6. Okay. Now, what is the probability of T in a single throw of a dice? Well, you have 1, 2. This is the possible outcomes of the throw of a dice. 1, 2, 3, 4, 5, 6. You have 6 events and only 2 of those, or 6 numbers, and only 2 of those numbers are divisible by 3. So necessarily, the probability of throwing 3 or 6 is 2 sixths, or in other words, 1/3. Okay, so the probability of T is 1/3. Now, we're interested particularly in 3 throws of a dice. Now, this throws of a dice are independent events. So, throw dice once, throw dice twice, throw dice 3 times, or throw a die even. I should actually correct the spelling there. It's actually a die, not a dice. But anyway, we'll continue. Probability of throwing a 3 or 6 3 times in a row. Each throw of a dice, a die even, is an independent event. We're going to call this event 3T. 3 times we get the same event. Now, or we get a number divisible by 3. So essentially, it's probability of T in the first throw, probability of T second throw, probability of T in the third throw. So all we have there is 1/3. It's 1/3 by 1/3 by 1/3, and if you want, that is 1/3 cubed. But anyway, the answer is 1/27, and you can get a decimalize that 1.03 something whatever if you want, but I'm happy enough to leave it there, not 1/27. Okay, so anyway, the key thing about this was that they were independent events. So we'll leave it there. Whoops.